Now that we have made some preliminary descriptive statistics and some simple graphs or figures, then we can move on to the statistics. And keep in mind that all statistics is made to answer a question. For example, in this case, we see that the median price in Oslo is higher than the median price in Trondheim. And that could lead us to the question, is the average price in Oslo different from the average price in Trondheim? Which is to say, is the difference between them statistically significant? In order to check that, we can use a method from the SciPy package or SciPy module called stats. So let's import stats. In order to install the module stats, we can either go to the terminal and write py-m pip install and SciPy. Hit enter, and you should see something like this. If you are going to use the terminal, you have to be in such a folder. If you only have these bars and not a folder, then you can just press ESC and get back to the folder here. So now we have successfully installed SciPy 1.11.1. So now we can use the methods and functions within SciPy. In order to do that, we need to import the stats from SciPy. From SciPy, import stats. So this is going to import what we need from the SciPy package. And as usual, we just paste the imports at the top of our code, and we can continue. So we just remove that one. So we need to pass in two different vectors here, the values for Oslo and the values for Trondheim. So it's easier if we just make two new vectors. For example, prices Oslo, which is data and price, and the price should be subsetted by city should be equal to Oslo. And then we could have prices Trondheim stored in prices Trondheim, and we could have prices and then only the prices where data is equal to city equal to Trondheim. So now we should have two, let's see, key error prices. Okay, prices, yeah, that's not a column. So that's it. Then we have these run, and if we have Jupyter variables here, and we have prices Oslo and prices Trondheim. Okay, so far so good. And now we can run the t-test. So from stats t-test, we have individual draws, and we have prices Oslo and prices Trondheim. And we can put this into a result, for example, and run it. But now the result will contain two values. So if we just write result here to show us the result, then t-test result is the t-statistic is 3.22 and the p-value is 0.004. It's better to actually split this result or the output from the stats function into a t-statistic and a p-value. So if we run this, then we see that we have a t-statistic here as a variable and a p-value. And these can be printed with a print function, but we are going to add some text to this print. So then we are using the f string. We just start with an f, and then we have the quotes, but inside the quotes, we can now put text and variables. Let me show you that. So then we can have the t-statistic, and if we just put the not these, but the curly brackets, the t-statistic into here. So any variables that you want to print out the value of, you put into curly brackets. So if we just print the p-value as well, and then we just have these curly brackets, and we have the p-value. If we just run this, then we see that, well, we have the t-statistic and the p-value. And of course, we can round these. Both the t-statistic, well, let's have 3. And we have 3 digits here as well. Then we see that we have our t-statistic and we have our p-value. And the null hypothesis of this test is that of no difference, which means that we are rejecting our null hypothesis of no difference because the p-value is below, for example, 0.05, which is a quite ordinary cutoff. This means that we have found statistical evidence for a difference in the prices in Oslo, the average price in Oslo, and the average price in Trondheim.